APAN Security Working Group session. My name is Yoshiaki Kasahara from Kyushu University. I'm a chair of APAN Security Working Group, and there are some co-chairs here. And today we have one 90-minute session, and we have two presentations, one from NECTEC, Thailand, and one from Malaysia. And then we want to announce something about our security working group and also some discussion about activities of security working group. So I'd like to introduce first presentation by Dr. Shari. So you can come here. Okay, so wait a moment. Okay, please come here.
Let me share slide. Okay. Yeah. Good afternoon. I'm Charlie Waragodipat from National Electronics and Computer Technology Center, Thailand. And, I'm at Information Security Research Team. So I'm working on cyber security and especially information security and testing on access control domain and some policies about legal issues and anything about security and privacy in Thailand. The title, as you can see here, it is about open source SOC. So I'm not sure if anybody here have knowledge about SOC before. Anybody? Okay, thank you. So there are at least two working on cyber security. So how about the other? Have you worked on cyber security before? Okay, thank you. So maybe I don't need to introduce anything much, and maybe all of you have more knowledge than me. Okay, right. The objective of my presentation here is just to introduce. It is just introduce SOC in manufacturing sector because we receive a funding from ICIF Asia to develop SOC, low cost SOC in Thailand. So when we talk about low cost IT system, what we can do is try to use open source resource because open source is free. So once if our cost is free, we can assume that human cost and price is also low relatively, right? But anyway, it is not easy. It is still a big challenge because how to convince Thai community or Thai people to use open source is not easy. I think it might be the same in this region, right? Okay. Okay, before I start, let me introduce something about cyber resilience. You know, when we develop SOC, what we have to do first is we have to adjust our mindset about cybersecurity. When we talk about cybersecurity, or especially in international standard like ISO 27001, they mostly talk about protective or preventive action. We have to protect or prevent from risk or threats or attackers. But for the new mindset, we believe that even you have good or excellent protective action, you still attacked. You cannot avoid ransomware. You cannot avoid virus. So once you get attacked, what you have to do is how to resume how to handle this incident. So it is the way that cybersecurity mentioned. If you understand NIST NIST framework, they mention a lot of steps, a number of steps of how to handle incident, starting from identifying risk, followed by protect, detect, respond, sustain, recover, and etc. And the concept might be slightly different based on the scholars or the others, right? So in here, what we have to do in cyber resilience, once we have to protect and detect, when we detect incident, we have to respond to incident because we accept the risk and accept to reduce. So this framework can result in development of SOC because SOC or Security Operations Center can help to handle the incident and starting from monitoring, detecting, and responding. Yeah. What is SOC? Okay, let me show you some definition. When we talk about OC or operation center, it is like a war room. As you can see on from the right hand side, it is anyway. This image is AI generated, right? So it's like they are working in at NASA or yeah something like that. But in a SOC in the real environment, it maybe just a few computers and monitors. But just want to illustrate how they work. SOC could be, yeah, it is a team. They cannot do alone. It is not a sole work, but it's teamwork. It could be company or outsource. In Thailand, some companies, they have their own SOC, right? Because they have money, they have ability to do, ability to pay, they have ability to train people. But some organization, if they have money, but they don't have the primary resources, they have to hire a SOC or they use SOC service from SOC providers. In Thailand today, there are a few SOC providers. But the thing is, they some organizations, they don't have awareness. They don't believe SOC is important because maybe they don't have cyber resilience mindset, as I mentioned to you previously, right? So what we have to do is we have to increase the awareness and then explain the importance of SOC and the mindset of cyber resilience. The job of SOC team is to detect cybersecurity events in real time and address and handle them quickly. So if you have worked in like CERT before, I think you understand. Has you been anybody work in CERT, the national CERT? Which country? From which CERT? Nepal. Nepal CERT. Okay. Thank you. Right. I've been in Thai CERT before, so I understand maybe protective action or preventive is not enough, and we receive incidents, requests, and every day. You know, in many organizations, they have KPI to evaluate cybersecurity measures. Maybe they measure from the number of incidents. Do you think it is good or bad, right or wrong? No, because we cannot say that if you have low level of low number of incidents, it means that your organization is strong, has strong level. No, maybe they don't just report. They don't report, right? But if you have incident and then you report and know how to handle, it is good organization. You are ready to deal with cybersecurity incident, right? Like ransomware. Have you been ransomed before? If your organization is ransomed and you say, oh, nothing, it means that your organization is ready, has good readiness, right? But if you just got ransomed and you feel frustrated and don't know how to do, Yeah, you don't have cyber resilience. Right, SOC benefit. Let's see what SOC can do. They do threat detection and response. Yeah, it is what I'm going to say that SOC and cyber resilience can do. They do continuous monitoring and analysis, because when we collect log data, you have to collect data from several systems within the corporate network, and use AI or use log analytic system to analyze the data. It could be rule-based or behavioral-based or anything that they can do. Overseen by security experts. In Thailand, we need to hire experts in cybersecurity, and the cost is very high. I used to talk with the vendors about the cost to monitor in the SOC in our organization, and they said that in 1 year they use 2 people, and the cost is up to 2 million baht. Very high, very high. Right. So yeah. Anyway, this is our new knowledge that we need to prepare budget for to hire SOC expert. Reduce cost of security incident. Yes, I would like to highlight you again that prevention cost is always cheaper than correction. You agree with me? When you protect, when you prevent, you can save cost in case you get incident. But anyway, maybe it's not always right if you fail to do risk analysis, because if you protect the low value asset, maybe you don't need to protect it. Just let it go. Then buy the new one, right? Like for example, if you have your mobile phone and your phone is very cheap, then you don't need to buy insurance or buy any protection, right? Continuous improvements of security posture. Yes, it is one of the process in SOC. Why smart manufacturing? In this presentation, I try to focus on the industry sector rather than ordinary IT system, because it is a condition of our funding from ICIS and our work at NECTEC. We focus on the Eastern Corridor, Eastern Economic Corridor in Rayong province. Do you have any knowledge about Eastern Economic Corridor? It is in Rayong. It's like a smart city in Thailand, and they are lead aside for up to 1,000,000, 1,000 manufacturers. And there are both small and big size manufacturers. So we try to introduce cybersecurity in these manufacturers, right? It is called Industry 4.0. And yes, they use OT, operational technology, rather than IT. Okay, this picture is demonstrate the difference between IT and OT. IT is just ordinary computing system in office usually, but for OT, mostly they use for manufacturing or industry, like SCADA or IoT. The main different thing is that usually IT is built by people, but OT is built with machine or robot, and the system is much higher and it operates 24 hours. That's why security must not be overlooked, because when the system operates 24 hours continuously throughout a year, it is a big opportunity that the attacker can attack anytime. Okay, for the modern OT today, hacker, IT, or to connect to OT, it must be connected through IT because IT is connected to OT, and hacker can use the vulnerability in IT system uh, and pass through the network at the OT system, as you can see here. So once the system is very complicated and very big, we have to use SOC because it is not just a few computers that a few people can monitor. We need to use high technology to do. It is the big challenge in Thailand. We need to hire professional, but it is very expensive. We don't have enough money. I think it is similar problems in this region, right? But for large company, large factories, they have no problem because they have money. Like CII, critical infrastructure in Thailand, they have no problem, especially financial sector or bank sectors or telcos, something like that. But in EEC, Eastern Economic Corridor, there are a lot of SME factories. They don't have enough money because they have to invest their budget to do their production, not for security, right? If I ask you back about how many percent of your IT budget to be invested in security, 10% or lower, right? So affordable security service is needed, and we come to help. NECTEC tried to come to help manufacturer in Eastern Corridor, but we can help. We receive funding from ICIF and develop SOC to them, and we use open source SOC. We have a few business models to do that. The first, our initial model is to develop SOC using open source and teach them to follow. We develop platform like a centralized SOC, or maybe just manufacturer, they have to install open source SOC on site instead. But the problem is that they're not still interested. They don't show interest in SOC again because it is still difficult to do. Like if I give you Microsoft Office and Open Office, you prefer commercial ware instead of open source because of familiarity problem, right? So another model is we may teach provider instead, because many cybersecurity vendors in Thailand, there are both big and small vendors. For big vendor, there is no problem. They can use commercial SOC. But for small, medium vendors, maybe they are willing to learn. So because at least they have service to provide the low cost, the customer who has low budget. And we are trying to do that. And we think we need to deal with cybersecurity agency, maybe national cyber agencies, and let's see if they are interested or not. Yeah, we have assumption. If we have lower software cost, it means that service fees will be lower relatively, right? Now let's see. The first step before we start monitoring, there are IT and OT. The difference between IT and OT is that at least the traffic in IT network, IT is less deterministic. It is unpredictable because IT system is operated by human usually. The main user is human. So you cannot predict human traffic. Sometimes you need to transfer a lot of data, sometimes not. So maybe it is a bit difficult to make the prediction or predict the future traffic, right? And most hosts, they have additional security to install because endpoint or client, it is controlled by human, and human can install any agents or any software. It is contrast, it is different from OT because OT is like IoT and everything is programmable. So everything is like robots. So the traffic is more deterministic. It is repeatable, predictable, right? So even there are more and more systems in manufacturer because there are a lot of devices throughout the manufacturer, but it is more predictable. Maybe it is a bit easier, right? To monitor, there are two types of monitoring. The first is host monitoring. They monitor hosts like client, computer system, ordinary computer or server, and they need to install agent at endpoint. It could be in both IT and OT network, and it is called host-based intrusion detection system or HIDS. Okay. For the second one is network monitoring. Maybe it is familiar to you. They capture the network traffic. It is opposed to the host monitoring. It is good for deterministic network. That's why we focus on OT rather than IT here. And it is called network based in IDS. Okay, it is just examples of difference between host and network IDS. For host, they have to install agent in at the computer, at client. And you know, when you deal with people, it is very difficult. Even you use centralized system to control them. So we switch on to another one that they use to monitor network. Yeah. Okay, what is HIDS? Here, it is real-time threat detection. Yeah, doing that to monitor activities like anomaly in the host. For example, there are malware or anyone who break the policy, cybersecurity policy. So the admin can see some anomaly and some suspicious behavior. Monitoring system integrity. Yes, like to check integrity of files or configurations, and also vulnerability assessment, and of course, and it must be friendly with any platforms, including any OS like Windows, Linux, or Mac OS. When we talk about platform or clients today, it is not only computer but it could include BYOD like mobile phone or tablet or some small size computer or maybe smart home. It is the first open source software for HIDS, and we just test WASU. Actually, I'm not going to claim that this open source is the best, but it is just the one that we have tested, and it could work well. And in the near future, maybe we have to study more. But at this time, we use WASU for real-time threat detection. Anyway, it is just rule-based analysis, and it is not still not behavior using AI, because I'm not sure if it is the limitation of the open source software, but if you have more example or better tool, just please let us know. Anyway, I'm in this room. I don't come alone. We have our research and engineering teams over there. So if you have more questions, you can consult with them. Okay. Right. It is an example of the diagram. They have to install a WASU agent in the clients, and the server and the centralized system can monitor and detect the monitoring to detect anomaly and suspicious behaviors. Next, NIDS, it is the same. They just analyze real-time network and deal with multiple protocols, in this case, instead of platform, including like HTTP, HTTPS, DNS, SMTS, and any protocol for suitable for IoT. As you can see here, it is still rule-based or signature-based. Okay. And, it is scalable and adaptable. And for network monitoring, we use SIG. And anyway, I think this should work well because not only us using SIG, but also we talk with Thai University. They also use SIG for network monitoring. And professors in universities, they use this one to teach students and ask students to try to set up network monitoring using SIG as test bed in university. In here, SIG, the benefit of SIG is they capture network traffic and they generate in the structure format like JQ or JSON or TSV format. And if you understand the structured text, it is very easy for analyzing data in the future because the size is very small and compact, right? And you can send to a programmer to you can reformat or to analyze anything in the future. Yeah, they support a lot of protocols like MQTT for IoT library and IMAP in email, etc. Right. But anyway, SIG is just network monitoring, but they don't do analysis. The next one is Suricata. Suricata is they do deep analysis of the network. So this could be IDS because they detect the intrusion, right? And it is still open source. And they have the rule base to detect. I can show you the example of the code in the how to detect DOS, denial of service in the Suricata. As you can see from here, we have a rule that we will send alert if there is an external TCP package sent to the system more than 5,000 times in 5 seconds. You send alert. So it is just the fixed rule that we have set before. Okay, but if the package is from within the local, they don't send any alert. Okay, this is an example. And the data that Suricata can use, they just use the data from SIG, from network monitoring, from structure text. As you can see here, it is IoT and you send the data, and SIG can collect the data in structure mode, and Suricata will report and send alert to check a suspicious request. And everything is, all of these are operated by SOC. Just example, right? For threat intelligence is almost the same, but they just collect and correlate data from several sources. And it is a centralized system, as you can see from the right-hand side. They analyze data, especially from logs. And as you can see here, the largest data in the network system is log. And if you don't have good analysis, maybe your log data is useless because the important objective, the objective of collecting log is to analyze and to detect. But if you have log data, but you don't do anything with them, maybe it's just a junk data, right? So once you have threat intelligence, you can have the data of threads and compare with the data from seek that you collect. MIST. MIST is open source software solution, and they collect the data and share. The objective is to share thread data to the users, and once they have thread data, we can compare the data from seek or from network monitoring in your that you collect from your corporate network. Okay, choosing database and dashboard. I just talked to the professor today during lunchtime, and he suggests that once you have good system, but you don't have good interface or dashboard, it is useless, because the one who make decision is maybe not you, but higher position, like executive or IT manager. So dashboard is very important. So if you are a developer or a programmer, if you just focus on programming, maybe it's not good if you overlook UI or UX. So in here, they suggest the use of dashboard, and also the data must be searchable, and they can search using full text search and schema free. So it is it's not complicated, and quite simple, and can scale, and etc. And also in open source is open source tool that we suggest to develop dashboard. But actually, if you use Wasu, you don't need to use OpenSearch, because OpenSearch is included in Wasu already. So Wasu is like all-in-one IDS and database and dashboard. Just have a try. Okay, this is the summary of the tool that we have tested in our open source SOC. For IDS, we use Wasu, and the client needs to install agent. And IDS network, we use Seek as monitoring system, and Suricata for deeper analysis. For database, we use still Wasu, and OpenSearch is included in Wasu already. The dashboard is the same, and plus Grafada. And for threat intelligence, we use MISP. Okay. Anyway, when I introduce a lot of functions and open source tools here, it doesn't mean it's like plug and play. Because it's open source, you still need effort, including your energy and time, and maybe human resources and money. But if everything is settled down, you can save a lot of cost, right? Okay, this example, client side and SOC side. It is like the big picture of everything I have presented before. Okay, the lesson learned. I'm going to end my presentation. Factories, they don't want to install software and setting up devices for everything. Actually, it is not the problem for manufacturing sectors, but maybe for this could be applied in any offices or any sectors, because people don't like to use a lot of efforts to do. The lack of network devices, they don't have enough IT staff, lack of property security measures. So OpenSOC could be the answer. Anyway, I'm not going to claim that open source is everything, but it depends on the context. If you have money, you have budget. If you are critical infrastructure, try to analyze the list if open source can work well in the organization. But we try to introduce to SME, manufacturers and office, or even for academic. Because my part, we are at Information Security Lab, and also I'm at SMC, Sustainable Manufacturing Center. This is a site or the center for learning, especially for Eastern Economic Corridor in Thailand. So we are here to test and to learn and transfer knowledge to all of you, and especially to Thai people and the region. Right. Okay, for our future work, we still reduce infrastructure costs because our main objective is to do anything that is fit with Thai context, that we have limitation of cost and human resources. Scalability, because we understand that the near future, the system, also data will increase drastically or exponentially, and it is the nature of the data, right? Okay, thank you very much.
Thank you very much. Any questions or comments from?
Thank you for your wonderful presentations, right? I have a couple of questions over here, right? Can you please elaborate more about the different framework you mentioned about the NASP framework, right? Apart from that, can you also explain others part? And another thing is, you also define OT and IT, right? OT and IT.
OT and IT.
Yeah. And you also saying like SOC, Security Operations Centers, using the open source tools, the SOC, the cost of the Security Operations Centers can be reduced. Okay. Can you just elaborate what is the SIEM and what is the SOC? The difference between SIEM and the SOC.
Okay. SIEM is like just to collecting log data, and SOC is more comprehensive because SOC is sort of the involving in ICT framework. As I mentioned you from the very first slide, that there are a lot of a number of processes, including identifying, protecting, responding, sustaining, and recovery. If you see the ingredients of SOC previously, it could be included in all processes in here, like in ICT framework. But for SIEMs, it's just part of SOC.
Thank you very much for that. And another question is like us, okay, as a security experts, what do you recommend to like any of the organizations to protect their informations, right? What is your recommendation? What is your takeaway for them to like maintain SIEM and SOC, right? And using the open source SOC or proprietary SOC, like not a SOC, proprietary SIEM. It might be from IBM, it might be from Logarithm, it might be from Flux, or it might be any of the SOC or Wazoo. You are saying the open source is also Wazoo, right? Which SOC will be best and why?
I think it is not a responsibility of a single person or single agencies, but it is for everyone. But for the main responsibility, responsible agencies could be, yeah, well, it can be a cybersecurity agency in Thailand because they are regulatory organization dealing with cybersecurity, right? But yeah, they are regulatory organizations, so maybe they focus on policy. They have to work or involve a lot of organizations like academic or research institutions like NECTEC, and maybe a lot of voluntary people, and yeah, something like that. And we are doing that. To be successful in cybersecurity, we need to set up a community to do that. And because uh, expert in cybersecurity, maybe they are not they are in the dark, the dark side, the dark area. So when we have community, it is a good way to attract them to come out and share knowledge with, among us.
Thank you very much for this kind presentation and the response as well. From the takeaway part, we need to enhance security awareness session for APAC region as well, right? And the bank, the financial institutions, the service provider, research and education network, they
Yes.
have to protect their infrastructures as well, right?
Right. Yeah. I've looked service providers from companies. Yeah, they are the main drivers to drive cybersecurity in Thailand. Right. Yeah. Any comment from my team? Yeah, we have to give credit to our team.
Operational technologies can be quite various, right? Can be like SCADA, DCS, IIoT, BaaS, or anything according to your target customers, the manufacturer in Rayong. So what are the OT systems that you are actually targeted for at the moment?
We just focus based on geography, because in Rayong there are manufacturers, and the manufacturers, each of them, they produce different products, but at least they are manufacturers. I think the characteristics of manufacturers are almost the same, because they have SCADA, they have system that operate 24 hours a day, they have IoT devices. Yeah, and that is, I believe that this characteristic could be enough to be called OT, and could be covered by our solutions.
Because all these systems are quite different. They are all proprietary protocol, right? And not really have general knowledge.
Okay.
Like PCS protocol itself, or SCADA, or BaaS, or some industrial IoT protocol also very, and they are very various and so different.
Okay, thank you very much for your concern. And we have maybe two answers. The first one is, if they are proprietary and everything is different. So far, we are going to do a pilot project. Maybe we start from a few manufacturers first, and just to test if our solution can work well. Maybe we can choose 3 different manufacturers, because it's the conditions of our scholarship from ISIC as well. And the second one is most OT today is connected with IT. Maybe we can focus on IT that controlling OT.
Because so at NECTEC, you probably need to acquire that equipment and that know-how of proprietary protocol to efficiently monitor it, even at the network, IT network level, when the traffic has come from all those systems. Right? So I think that SCADA, PCS, or BaaS, or some kind of OT, so they are so different, and all are very proprietary, actually very proprietary protocol as well. So that can be a lot of challenges.
Yeah, thank you very much. I think especially IDS to check anomaly, it could be different, like machine or motor or.
But I feel that that's great, because that industrial part of Rayong would be all those manufacturers should be should benefit from this project, because it's, as you say, it's very hard for some small manufacturer that can acquire the socks by themselves, and if the government have some initiative or some organization that probably can be helpful for them, that should be very benefit to the country. And I think that's a great one. I think. And so far, have you find any typical vulnerabilities from that targeted size? What is kind of typical vulnerability that you found so far on that OT system?
Usually, it could for manufacturers, it can be like DDoS or something that attack availability. It is different from IT because IT mostly it is confidentiality because the data is generated by human and it is understandable by attackers. But in here, maybe they just attack to stop the services and also integrity. So.
Right. Just as one short question. I'm had a question about the connection diagram. It's like when you put something into the system, there might be some questions about additional overhead that might be problematic. What do you think about this?
I think this problem might be connected to scalability and compatibility. Mm-hmm. And we are going to do that over the next pilot project.
All right. Okay. All right.
Thank you. Can you show the chat? There is one question from remote side. Can you answer this briefly?
The question is how to deal with distinguishing data from multiple clients. It is host IDS, right? And I think, I mean, from the base of my knowledge, it's like the centralized system to deal with a lot of clients in organization. It's like, I'm not sure if I'm wrong, like centralized anti-malware that detect the clients in organization. I think the mechanism is the same. If I'm wrong, please help correct.
Okay. Thank you very much. I think I'd like to proceed to the next presentation. So thank you very much for your presentation. Thank you. So I'd like to introduce second presentation by Dr. Shankar Karuppayah. Thank you. Please go ahead.
Okay, so good afternoon, everyone. So welcome to the talk. My name is Shankar Karuppayah. I'm from University of Science Malaysia. So the presentation that I'm going to present today is Talking Dead, Resurrecting Dead Zombies. So it's not really about zombie movie and so on, but it's about malware. So I'm going to talk more about it. Sorry. Got it. So what you can expect in the next 30 minutes or so is that I will be introducing you to what is peer-to-peer botnets, how are they being monitored by researchers in general, what are the challenges associated with botnet monitoring, and the last part, which is our work in progress on how to resurrect them for research purposes. Okay, so I'm just going to focus more on peer-to-peer botnets, but so I'm going to speed up on the background part of it. So what are botnets? Basically, you have malware-infected device, so you have devices that are connected to the internet that's being infected by some kind of a malware that has a remote control mechanism. You sometimes call it a C2 or CNC mechanism. which is then being controlled by a bot master or a criminal to issue commands to say, okay, attack here, attack there, so on. And this is what we will call as a botnet, right? So in short, or another definition here would be, you have internet connected devices all around the globe that's infected and being controlled by a bot master to carry out attacks and so on. For example, you can instruct all the machines to carry out a DDoS attack on a web server. And in 2020, DDoS traffic has peaked to 2.54 terabits per second. Most of our organizations will not be able to actually handle this kind of attack traffic at all. And those were just from infected machines, meaning some of your machines might even participate in those kind of DDoS attacks. So there are also other kinds of attacks, other kinds of ways where the bot master can actually make money. One of it is pay-per-click, so you exploit it. So there was a botnet called Zero Access in 2012 that has been reported to milk around $100,000 a day just by using 1 million infected machines all around the world. So there's a lot of money that can be generated by the cyber criminals. So how do they control that? So you have these guys, right? So these are infected machines. The typical architecture, the typical way of controlling such botnets will be to have a centralized command and control server. You can imagine this as an infected web server, or back then you have IRC servers and so on. I'm not sure if all of you here are aware of what's IRC, but if you know, then you're old enough. So the bot master can actually issue a command to the C2 server, and that command will be then adopted and executed by the bot masters, the infected machines to carry out, for example, DDoS attack. Now, centralized architecture or centralized botnets have two issues. One, this kind of architecture, where it's centralized like a star topology, it's a single point of failure. Removing that means the bot master will not be able to talk to the bots. And it's also a single point of monitoring. If the law enforcement agency is able to get the logs of the web server, you can easily identify the IP addresses of the infected machines. So it's easy to set up, but it's easy also to take it down. Now comes the peer-to-peer architecture, where you don't rely upon centralized servers anymore. In fact, all the infected machines will establish something called an overlay, which is a connectivity or overlay connectivity to a subset of other nodes in a way that all of them are actually interconnected. Okay, so in a peer-to-peer architecture, bot master will issue a command anywhere, so he can pick any node he wants, and that information will then be propagated to the other nodes in a hop-to-hop fashion. It's a bit slow, but the bot master has the benefit of having anonymity because no one knows where it's actually issuing it from compared to the centralized architecture. If you're talking about recent trends, although I call it recent, I have data here until 2019. I just didn't update this slide. So 2006 was one of the first peer-to-peer botnets that has been reported. But if you realize here, between 2011 and 2016, there has been a big gap. Why so? There has been a lot of law enforcement agencies around the globe that has been going hard on taking down peer-to-peer botnets. For example, the Kelly Host botnet, Zero Access botnet, Game Over Zoos, and so on. So there was a lot of effort in taking down. As such, we didn't see any new botnets emerging at that point. But 2006 to 2011, we saw a lot of Windows-based meltdown. And if you know about Game Over Zoos, this guy here, Bogachev, has been issued a notice by Europol and FBI for a reward of up to $3 million US if you can give any information about taking him down. It's still valid until today. So that's how big is this whole syndicate going on. So from 2016 onwards, we started seeing a lot of Linux-based malware, especially after the Mirai botnet source code has been leaked. So it has a different kind of variants. So you have different kind of infections coming up and so on. So I'm not going to go into the various details of the types of botnets and so on, but suffice to say that we have Linux-based botnets and a lot of IoT-based botnets, which means anything that's connected to the internet right now is susceptible to peer-to-peer botnets easily. So right now I'm going to give you a crash course on how peer-to-peer botnets work. Let's for a moment assume that these are the entire topology of infected machines. So this is how they're connected. Each of the boards in a peer-to-peer botnet has something called a membership maintenance mechanism. Let's call it MM in short. This mechanism ensures that everyone is connected all the time. Now, each bot will also have something called a neighbor list. You can think of this as a phone book. How do you remember how to contact your friends? You have a phone book, you call them based on this information. So in peer-to-peer botnets, they also have this information. And here I'm giving an example of up to 3 entries, but typically we have seen between 50 to 1,000 entries in any peer-to-peer botnet that we have seen. And the nodes that are appearing in this neighbor list are called super peers. But in short, they are having public IP addresses that can be reached from any part of the world. So super peers, if you look at this example, node D is connected to E, F, and G. Therefore, the neighbor list of node D will look like this. E here would be a combination of IP and port, obviously. Okay, so as it is with any peer-to-peer system, you don't know when your neighbor is actually leaving the network. As such, there's a mechanism to check if they are there, like it's a heartbeat mechanism. You can call it hello messages with a fixed interval. We have seen botnets adopting 256 seconds and one up to 40 minutes. So every 40 minutes, they'll send this message out to all of their neighbors based on the neighbor list. And depending on the replies they get, they will know which neighbors are actually online. So in this case, E and F is online, but G was not able to respond. Maybe it went offline, maybe it has been cleaned for whatever reason. So D will assume that G is inactive. Now, if there is a case where E, F, and G also being inactive, bot D will be automatically disconnected from the network. So there's another mechanism to request for additional neighbors. So D can ask either E or F, hey, can you give me some neighbors that I can consider? In this case, let's assume it asks for F. F will say, yeah, I was responsive. Why not you consider I? With that information, D will then replace G with I, and that's how D remains connected in the overlay, and anyone that is offline will be removed. So peer-to-peer architecture is beautiful in such a way that it's self-healing, self-organizing, and the bot master don't have to actually worry about this at all. Everything happens by itself. So that's why it's really, really interesting for me. Let's put it that way, right? So the other class of botnets, bots are called the non-super peers. These could be nodes behind NAT, like your home network, or nodes behind nice firewalls, stateful firewalls. So these guys will not appear in the neighbor list at all because you can never, so these nodes cannot reach to them, but they can actually reach to the super peers. All right, moving forward, there's one important feature which I want to emphasize here is bootstrapping. Whenever a machine gets infected, assume that I'm an existing infection, I'm infecting your machine, whichever way, there is this process called bootstrapping. So the bootstrapping allows me, well, you being infected by me, let's assume that you have an IP called 1.2.3.4, and you will actually inherit my neighbor list. Whoever that I knew as my neighbors will be inherited because I infected you. I also gave you the phone book that I had. And what you will do is you will actually establish a connection to this, what we call bootstrap nodes. That's the way that you can get into the to the botnet. Now, typically, peer-to-peer botnets will have two services. One is the client side, one is the server side. And it will bind to a dedicated port. Let's call it server side with this color for now to receive unsolicited requests. And another one, which is which will use ephemeral ports for client-side communication. So a common bootstrapping process is to ask one of the neighbors to check whether I'm reachable to others. So this is how it will happen. You will use the client side, the ephemeral port, to send the information, of the server port that you're listening to the existing neighbor. The neighbor will then establish another communication back to your server port to see whether it's reachable. So this is how you distinguish between super peer and non-super peer. So let's assume in this case, the communication could get through and then you reply. I mean, the new infected machines reply. So the existing node knows that node 1.2.3.4 is reachable over the internet. That means this is another super pair. So typically, this guy will add this new IP into the neighbor list. Remember earlier I said, when nodes don't have enough neighbors, you can ask others. This is the bootstrapping process allows new nodes to be shared to other nodes. So that's why I'm actually emphasizing on this. Okay, I think we can skip the next part. The next part is just an example of what happens if you do not have reachability. Let's assume you have a NAT device here. After a timeout, the neighbor will assume that you are not reachable here and then will not add you into the neighbor list. That's why I said in the neighbor list, you'll only see super pairs. Right? Okay, good. And there's an update mechanism. The update mechanism is how the bot master will issue a command. So I'm simplifying this. There are many ways of doing this, but it's typically a combination of a push-based or a pull-based mechanism. Now let's assume, remember again, I'm sending the heartbeat message or hello message to check if my node is my neighbor is there. And let's assume the last known command from the bot master has a sequence number of 100. Right? Just assume. So whenever I'm going to send this hello message, I'm going to actually append this information that 100 is the ID of the last known command that I've received. And whenever my neighbors receives my hello message, they will also be able to see what is the latest command that I've actually received. Assuming our neighbor has a new command, a sequence number that is higher than what I have actually announced, the neighbor, when replying to my hello message, will then append the new command to me. And that's how I get updated with what's happening or what's the latest command from the bot master. Okay, so eventually everyone will get the updates, but it's a slow process, but eventually everyone gets it. Now, this is a very big lecture portion that I've created, but I'm just going to focus on one thing. So the following is what I call the peer-to-peer botnet threat mitigation lifecycle. There's 3 phases. The first phases is the detection phase. Upon the inception of a malware, a new malware, you need to actually detect it by a combination of IDS or honeypots and so on. After you discover a new malware, you will have to spend quite amount of time to reverse engineer the malware to understand how the malware is actually communicating. And then you go into the monitoring phase, which I will go into detail in a short while, before you try to do remediation actions to take down the botnet. So let's focus on the monitoring part alone, which is the focus of today's talk. So the reason we're doing monitoring is to actually enumerate infected machines. So we have machines that are infected. We need to know what IPs are they from. These IPs, again, like what Dr. Charlie has actually explained, can be used as their own source of indicators of compromise. If you have any machines in your network communicating to these IPs, then you could be, it could actually be an indicator that another machine in your network is infected, trying to talk to a botnet. And this information will be helpful to actually do cleanup campaigns and so on. In a more ideal scenario, we want to take down if there's any drop-off servers. So if they're dumping stolen credit card details, we want to take them down. And this is a bit unlikely, the bot master attribution. We want to know who's the person behind the botnet. So again, we want to do this through monitoring as well. There are 2 ways of monitoring. The first one is called crawlers. The second one is called sensors. So what are crawlers? Basically, they are a small program written by researchers that has the protocol, because we have already reverse engineered that, and has the seed list. This is basically the neighbor list of the binary we have just reverse engineered. So we will create normally in a Python or C-based program to implement this protocol. And based on the seed list, we will send the message to one of the neighbors in the seed list that we have discovered. Let's assume it's A. So the crawler will actually send a message to A. Now, at this point, A will not be able to distinguish whether we are a bot or a crawler because we speak the exact same language as all other machines. And since it's they will have their own custom protocols in terms of encryption and decryption. So this crawler has implemented all that. So from a network perspective, you cannot distinguish that. So A will assume, this guy needs additional neighbors. I will share the neighbors. So A will say, B, C, and D is my neighbors. When I receive this response, at the back of my crawler program, I know A is connected to B, C, and D. Now I iteratively, using some graph search algorithms, repeat this process and pick another node, let's say D. Now when D gets this, D will say, yeah, I'm connected to E, F, and G. Now I'll repeat this process exhaustively until I'm able to rediscover the entire topology in my directed graph format, basically, right? Now, the problem of this monitoring mechanism is how I mentioned earlier, you can only reach superpairs. That means you can only reach between 10 to 40% of the entire botnet. You lose the visibility of 60 to 90%, right? This is the first mechanism. And this is how one botnet is visualized. This is Game Over Zeus back then. The blue dots are nodes. The green lines are actually the edges, who's connected to whom. So the big ball in the middle are nodes that have themselves into the enable list. So this is just a layouting. Okay, so I mentioned about crawlers. The next one is sensors. So earlier I also explained that from time to time you have to send a periodic hello message or heartbeat message. So we are going to exploit that mechanism. Again, you need to know how the protocol works. Then we will bootstrap the